Thank you so much for sitting down with us, Eric. We're super excited to be chatting with you, and really glad you're taking the time to discuss AI in the future with us.
And Alex, thank you for all the help you've given me in strategy and AI over the last few years.
Well, so I want to really dive into two main topics. The first is AI in the New World Order, and the second is the AI industrial revolution. But before we get there, you were at Google through many formative years of AI development. Many modern techniques of AI were actually sort of invented or strongly developed at Google in your time there. And I'm kind of curious, the past decade or decade plus has obviously been this incredible boom for AI and its emergence. But what was your first aha moment with AI? When did you first realize the potential of the technology and what the sort of like massive potential in the world could be?
Well, it was really 2011. What happened was a group of people, including the founders, I think, of this movement, did an experiment where they analyzed YouTube, trying to figure out what they could find. And they discovered the concept of cats using essentially unsupervised learning as we know it now. And it was quite interesting because we always thought there were a lot of cat pictures in YouTube. But the fact that that's what it would discover after looking at the corpus of YouTube information was rather disturbing. But all of a sudden, that started the prospect. A group inside of X, Google X, created a group called Google Brin. And that group began to build what you know today as BERT and Transformers and the other systems. Google had been using various forms of machine learning for advertising for a long time. But the fact that we then had a language model and we had an ability to do predictive text and we could actually look at binary synonyms and so forth allowed us to materially improve both search and advertising. Today, my opinion, I'm no longer there, is that much of the gains that they're seeing in revenue and in search quality are actually coming from the technologies built starting with Google X and discovery of cats in YouTube 10 years ago. At a similar time, we also purchased a company called DeepMind, which seemed impossibly expensive when we bought it, and today looks like one of the smartest decisions ever made, because of course they're the leader in reinforcement learning globally.
Yeah, no, it's absolutely incredible. I think to your point, the impacts of these technologies, they're so deeply embedded now within these large technology products that it's almost impossible to imagine what the gains would look like without these incredible technologies.
Well, I can give you a simple way of thinking about it, which is AI companies are defined as companies that do something involving learning. And if you think about it, if you're a consumer tech company, the more clicks you have, the more learning opportunities you have. So here you have a situation where every action at Google you take, you have a learning opportunity for both the quality of the answer, but also the quality of the ad. Now, the goal 20 years ago was to end up with one search result, one ad, the perfect search result, and the perfect ad. Well, this technology may get us close to that in the sense that the understanding that you get from learning what works in this situation, in this context, is so powerful. And the interesting story inside of Google was that in both cases, the traditional teams, the normal teams, if you will, who were doing traditional algorithmic programming, who were brilliant, I might add, right, had brought the company to this point, we created a competitor in the form of a machine learning model, typically built on top of what you would know as TensorFlow, using the same amount of database and so forth and so on our fast TPUs, and we would see what would happen. Often, the interesting thing is that the computer did not come up with a very different result, but it got there in a very different way. So what would happen is you'd run the tests, and then the traditional team would look at what the AI was sampling and would say, it never occurred to us that there was a correlation between A and B. So if you believe at its core in the last decade, AI was good at looking for patterns that humans couldn't see. Just mathematically, it couldn't see them. Then that produced a lot of the gains. Now, the same is actually true in inverse, which is now generative models, which is what everyone is doing, have the property that they can both be used in things like GANs, but you can also use them to generate something new, which is the next stage. So think of that as prediction. So we went from deep understanding, and because we had the understanding, we could predict the likely next outcome with some certainty. Well, that's very powerful too. So if you go back to the consumer tech companies, just to close it out, why have the consumer tech companies gotten so excited about this? Because it directly improves customer quality, directly improves customer revenue, and it also allows individual targeting to the person or the cohort that the person appears to be part of without having to profile them. Now, it's important to say that it's not perfect, they make mistakes and so forth, but that's driving this huge increase across the board.
Yeah. And I actually really want to, this will be a discussion topic later, because one thing that I want to dive in with you on is what is the fundamental change to business models that AI helps enable? So, but to kind of dive into our first primary topic around AI and the New World Order, one of the things that we've spent a lot of time talking about is what does AI do to governments, how governments need to interact with one another, how they interact with their citizens. And there's a lot of pretty deep sweeping changes. And so kind of taking a big step back, what geopolitical trends do you see that will ultimately impact the long-term benefits of AI? And what are sort of the important shifts that we should be paying attention to at kind of like the global level today?
Well, I would say to start with that the most important competition is not going to be Google versus Apple or whatever. It's going to be China versus the United States. And let me make the case for it. We all understand how the power of America, our innovation model, we're the envy of the world. This was an accomplishment from people over 70 years, essentially since Vannevar Bush, maybe 80 years, to build a system of research scientists, innovation, and so forth. It brought us GPS, it brought us semiconductors, it brought us the internet, all of the things. It brought us social networks, etc. Everything that you could imagine came out of that maelstrom. China has a different model, but an equally powerful one. They've got 4 times as many engineers. They've got a huge number of companies. As you know, because we've looked at this, the companies work 996, 9 a.m. to 9 p.m., six days a week. By the way, that's illegal in the United States. Don't do it here. So you have a work ethic, you have a profit motive, and you have a scale of platforms that China can exploit. They'll be exploited differently. But the important thing is that both the US and China are large enough markets to make their own weather, right? They're so big, they generate their own storms around each other. They create platforms that are unique within their own domain. That is a stable structure for the rest of our lives. And unless something changes materially, I don't think we're going to see one internet. I think we're going to see this splintering, at least at the applications layer. And the fundamental reason this is occurring, in retrospect, is the internet, when I was doing this at Google, was essentially optional. You could do everything without it. You could do it with it. People like you and me thought it was really cool, and it worked really well. Today, the internet is no longer optional. The internet is fundamental to everything. So every form of human activity occurs on the internet, including the ones you don't like. And if you look at China, the Chinese have solved the internet problem in their own way. They've criminalized or made it impossible to be anonymous on the internet. Well, that cuts down a whole bunch of stuff. So all of your speech is recorded, and you can be, again, the police can prosecute you and using their laws, which are quite vague in these areas. So it's a very different internet. They also don't allow the American companies to operate, and we typically don't allow them to operate in our country, with the notable exception of TikTok. And so the result is 2 different information spaces, and those information spaces will shape the outcomes. Because people take the cues of the information space. In the tech industry, and you and I have done this for a very long time, the tech industry has its own sort of sociology. It's kind of a certain worldview. It's somewhat libertarian. It's quite liberal in terms of personal behavior. It's relatively conservative financially. It has its own little political zeitgeist, and it's big now. But I learned a while ago, and I'll say it to everyone, we're not the same as everyone else. The fact that you and I and everyone watching this are tech people, we are a minority compared to most societies, probably thank goodness, by the way, and we need to respect the fact that they operate in other ways. I think that to answer this, to be one level more specific, China is building an internet that makes sure that China remains in power, that it maintains what it considers an appropriate level of control over its citizens. You see this in the surveillance and in social credit systems and all of these things that are at various levels of deployment. Now, I'm not a Chinese expert, and you know more about it than I do, but I would bet that their strategy is going to work, that the technology that they're deploying will be successful. I'm not endorsing it by my saying that. Please don't take me out of context. I'm simply saying I think that they have a strategy, they have the resources, and their directive. The last time, 2 times ago when I was in China, I was with the minister who regulated us, and he gave a speech, which I attended, where he explained that the only solution to the problems on the internet was regulation. They're not hiding behind what they're doing. They know what they're doing. And it means that, I'll give you another example. It's very hard to get a VPN now because the VPNs use machine learning. The system, the Great Firewall, uses various forms of machine learning to try to find them. Right? So that's another example of a small thing, but it added all up, they're very different. So having said that, the next question is, what do the other 195 out of 197 countries do? And a reasonable prediction is the democracies will form around this U.S. Western consensus. And the democracies, by the way, include Japan, South Korea, India is a democracy. And the countries that are fundamentally authoritarian, or they're so weak they can't tell what they are highly likely to be influenced by the Chinese architecture because they benefit from it.
Yeah. Well, one thing that's pretty curious is that there's, China is the biggest lender to a huge percentage of the countries in the world. They're also the biggest trade partner to many, many countries. I think the biggest lender to something like 70% of countries or whatnot. What do you think happens to countries that are sort of in the middle? Ones that are highly dependent on China for economic activity, but also ideologically are more aligned with democratic values in the United States?
Well, a good example is Australia. And Australia, over the last year, has taken a very tough stand against the demands of the Chinese to essentially quelch certain kinds of dissent and other, if you will, interference in Australian affairs. And they've done that knowing that by far their largest trading partner is China, and China is central to their future growth. So far, that strategy has worked. I think it's reasonable to expect that the BRI countries, the so-called Belt and Road Initiative countries, will all become essentially clients, if you will, of the Chinese information space. So it'll have the Chinese information rules, which include surveillance and some forms of censorship, because literally they're going to get their technology from China, so they sort of get it for free. To me, the hard question is, what does Germany do? Number one, business partner of Germany is not the US, it's China. Right? The companies that I have spoken with in Europe most recently are that have their number one international market is not the US, it's China, and their number one supply base, the things they buy come from China, not the US. Now, I think they're going to stay in the Western fold for 100 zillion reasons, but they're in a tough spot as this division occurs. I'm not suggesting that we're going to fully decouple. What I'm suggesting is that we're going to have an incredibly uncomfortable competition with China, where China will uncomfortably force people into these spots, and they'll have to make tough decisions. So if you go to the leading countries, the leading Western partners, we're going to keep them. You start to wonder about countries like Hungary, as an example, which is having trouble deciding how closely it wants to follow EU norms. I think they'll probably stay in the West. But let's pick my favorite example, Tunisia, which is a fantastic country. They don't make much. It's very nice people, very well run by comparison to its peers. It will have more money and more opportunities with China than the US. How does it decide?
Right. And especially when we think about how this pertains to AI, and we've talked about this, there are sort of 2 ways to do AI. There's one way in which you do AI, which is sort of authoritarian in nature. You're focused on massive data centralization in a relatively unambiguous way. And then there's ways to do AI in which you're far more mindful of bias and ethics and privacy and all the things that I think, in the Western world we think are really important. One interesting front of this battle has been that China has been leading the creation of global norms on AI. And there's certainly this sort of conflict around the standards of AI. And one thing I'm curious about is, how do you think this ultimately will develop? Do you think this is just yet another front of a general bifurcation? And what can be done to sort of avoid a paradigm where the sort of maybe the more authoritarian regime of AI becomes the dominant one globally?
Well, I think the fight is underway, as you said. And everyone focuses on the fact that China has more data and less privacy rules. I will tell you that the commission that I had the privilege of leading, which finished its work a few months ago, called the National Security Commission for AI, appointed by Congress, found that algorithms are just as important as data, and that we recommend a number of things, perhaps the most important of them for universities, in addition to doubling research funding, which is sort of a no-brainer, is to build a national research network. And the idea is that the big companies, Google being an obvious example, have tremendous hardware, tremendous scalability. But little startups, smaller research groups, those sorts of things don't have it. So a number of universities have put together a proposal. I'm familiar with the one from Stanford, and we're working hard to try to get that funding into the NDAA. The NDAA is the yearly appropriations bill for the military and national security, along with a number of other things. But what I would say is we can't win by adopting somebody else's good practices. We have to take our good practices and make them stronger. How did we get here? First, we allowed high skills, high value immigration. Sort of a no-brainer. Most people would prefer to work here than in China if they're not from either. They prefer to work in the West. Why don't we let them in? Why don't we work hard to increase our research funding and also work hard to get more talent into our government? Government has a lot to say about how these things are doing. Remember, the American government is very complicated. All the states, all the federal regulatory bodies, which are allegedly independent, and then you have the White House and the military and so forth. These are huge operations. They have relatively little technical talent to even understand these debates. Most of the AI work that you see coming out of them has been done by volunteers, outsiders. I worked for the Defense Department for 5 years as a consultant, and as part of that, we produced an AI ethics proposal for the DoD, which it adopted, which is one of our better wins. So it can be done, but it requires all of us. Let me just get on my soapbox for a sec, sorry. This is a national security challenge for the United States. If you want for the next 20 or 30 years for American technology, American values, American startups to be global platforms, we need to get our act together now, because our competitor, by the way, they're not our enemy, but they're our competitor, China, is busy doing that exactly. They're doing it in energy, transportation, electronic commerce, where they're already leading, surveillance, which they're already leading. They're working very hard in quantum, where we're still leading, I think, and they're working very hard to catch up in AI. I'll give you an example. In March, we said that we were 1 to 2 years ahead of China in AI. In June, they demonstrated a universal model of a size similar to that of GPT-3, OpenAI's GPT-3, which is a significant accomplishment on China's part. Now, maybe it's not as good, but the important point is they know what they're doing and they're on their way.
Yeah. One question that naturally comes out of this, I think you've kind of said in the past, hey, the government is not prepared for the ways in which digital technologies and AI are going to completely change the way that systems work. And I think to your point, I think it's very important that governments have more technical talent so they're able to sort of see around the corner and understand what are the overall implications around how the system will evolve in tandem with these digital technologies. What do you think are some of the key ways in which the government needs to be thinking about in which the system will evolve? And therefore, what are the sort of the key initiatives that matter a lot outside of just ensuring that we have an innovative environment where we're building the great technologies?
Well, let's start by saying we need to have an innovative environment where we're building the great technologies. Let me observe that the vast part of the innovation is occurring in private companies. 50 years ago, the vast amount of this kind of innovation was being done in government labs and in universities. So it's crucial that the tech industry be allowed, if you will, to go as far as it can with these technologies. And one of the issues is people like to prematurely regulate things that have not occurred yet. So why don't we wait until something bad happens and then we can figure out how to regulate it? Otherwise, you're going to slow everybody down. Trust me, China's not busy stopping things because of regulation. They're starting new things. So that's the first point. I think the second point is that we have to remember that in a national security situation like this, we actually have to have a coherent national plan. If you take a look at Operation Warp Speed, you had a situation where universities invented mRNA, private sector built the vaccines, and the government guaranteed the market whether it worked or not. I don't know whether you want to call that industrial policy, you call it what you wanted, but it was in and under Trump. And it was a national emergency where we were very, very and correctly worried about it, and we innovated. And by the way, BioNTech, which is the source of Pfizer, is a European, actually German company. So there's lots of examples where if we put our mind to it, we can do this. Now, it requires leadership at the presidential level. It also requires shifting resources. What I found in my work with the government is that everyone gives speeches all the day about what the government should do, but the government only does what it's supposed to be doing at the moment, and it tends to self-propagate. So if you want to change a company, you change from customers and bottom up. If you want to change the government, you have to start from the very top and go, it's very directed. Another example with the DoD was they have a process which is internally known as the POM process. The funding for AI was proposed, and then you have to wait 2 years for the money to show up. And then you have to get the deployment plan and so forth. It's built around 15-year weapon systems. Now, we managed to find a way to get around that, but it's a good example of how the systems aren't capable of rapid change. And if AI is anything, it's something which normalizes an awful lot of data and provides new insights. And we should spend a minute and talk about how powerful AI will be, for example, for science, right? It will transform our understanding of biology and chemistry and material science and all of those kinds of things. Those are the basis of the next trillion-dollar industries. You know, the trillion-dollar industries that exist today are in software. Thank goodness, that was, what I was doing. And the next generation will be in the application of digital technology and AI in these other industries, which are huge, right? So think about drug discovery, healthcare, 18% of GDP today. Anything that you can do that materially affects that is a huge company.
Yeah. No, I'm really excited to talk to you about it. And in a sec here, we'll talk about sort of the AI industrial revolution. And I think it'll be a great topic. But just kind of motivate what you're saying right now, as part of the National Security Commission on AI, you came up with a list of recommendations. And I think one of the things that you just noted, which I'm very sensitive to, is that the timelines upon which governments implement these sorts of recommendations can be quite long. It can be years at a time. It's not months or faster. And what do you think the urgency here is? What is the time window in which we need to be operating in to be successfully competitive?
Well, I'll give you an example of TikTok. So TikTok is taking the world by storm. It's extremely popular in the United States. President Trump, using a series of tactics, tried to get it changed, tried to get it to be the U.S. operation, hosted and owned, most recently on an Oracle platform. None of that actually happened. So TikTok is a good example of the first real breakout platform from China. And by the way, it's a high-quality platform. And much of its apparent success is because it has a different AI algorithm for matching. It actually matches not to who your friends are, but rather to what your interests are, and using a very, very special algorithm. So that's an example where I would have told you that would not occur for another 5 years. So we have relatively little time, maybe a year or two, not 5 or 10, to get ourselves organized around the initiatives that we raised. To repeat, more money for research, building a national research network, working with our allies, establishing guidelines and ethics rules that apply to everything that are consistent with American values, the hiring people into the government. We make a set of, in our report, we make a set of very specific recommendations for how the Defense Department and the intelligence communities should work. And they're typically of the form, take this function and make it more senior and give it more resources. We also make a couple of other suggestions, including creating a civilian university for technical talent that would be free in return for up to 5 years of work in any form of government, not just the military. And we also have a proposal for a reserve corps where people would spend, it's modeled basically on ROTC, where people could spend up to 30 days inside the government helping them and then go back to their jobs in a legally supported and promoted way. There are plenty of people who want to help our government get to the right outcomes here. They want national security. They care about doing things the right way. They want to do it with right ethics. They want to be involved. We can do this.
Yeah. And then, just as a closing thought here, I know, I agree with you. I think the urgency is really there. It is sort of a question of the next few years, not a question of the next decade, in terms of the initiatives and what we need to drive. What are some of the most critical and existential problems that could arise due to AI technology, there being a mismatch in AI technology between the US and China? For example, it's not a fun day if China builds an AI that is able to silently execute complex and difficult to track cyber attacks. And so
I think there are simple ones that are obvious. It's a balance of power in terms of cyber. So you could imagine an offensive cyber weapon or a defensive cyber weapon that was stronger than anyone else's. And that's kind of an obvious argument. One of the ways the military thinks about this is they think, okay, well, we'll take the people who build that and we'll put it in the equivalent of Los Alamos and we'll keep it a secret. But one of the things that's different about AI is that there's almost no containment of AI. The technology leaks, literally the ideas leak so fast that you don't have much advantage on one side or the other, which is sort of a new grand strategy, stable paradigm problem. That's the way I would describe that. Let me give you an example of AGI, which we'll talk about. But let's imagine that let's assume that there are 10 countries that are working on AGI, and that you end up with 3 or 4 in China, 3 or 4 in the US, and a couple sprinkled around, including one in Israel and a couple in Europe and so forth. Maybe one in Russia. You get the idea. What happens if one of them invents something that the rest of them wants that's really hard to steal, right? So, I don't know, not a good example, but they figure out how to cure cancer in a way that nobody else can. So that would be bad. Well, now let's take it one more to the extreme. Let's imagine that one of them builds a system that's so dangerous that we don't want even that country to use it. So, for example, it can answer questions like, how do I kill 1 million people tomorrow? It's hugely dangerous. You clearly don't want to make that happen. It's reasonable to expect that, again, in our lifetimes, that there will be the equivalent of nuclear non-proliferation discussions under a new regime where we're trying to say, these things can be built, but we don't want very many of them. And we want to keep them under some form of guard, and we don't want extreme terrorists using them. And we only want them to be used in certain situations, even by their owner governments. So I think that's the thing that's changed in the last 10 years is the aggressive use by governments of cyber and influence and the Russian interference in 2016. That's all new. It didn't happen 10 years ago. If you take it to its logical extreme, then you're going to end up with things which are as dangerous as nuclear or close to it. And we don't have any language by which to discuss what does balance of power mean, how do we keep it under control, how do we make sure that the equivalent of the plutonium doesn't get leaked, right? There is no analogy. We haven't figured out that doctrine yet. And if we don't, then you're going to end up in a situation where China has a poor level of security around its AGI. Somebody copies the network inside of it. They copy it onto the equivalent of a USB stick, and they take it over to another country where they're not subject by that rule, and something bad happens, right? So we have to have this conversation. I'd rather have it now.
Yeah, no, I think it's a great call to action. I mean, AGI and AI in general as a technology that's as powerful potentially as nuclear weapons in sort of the previous age, but with very different properties. It's very easy to replicate. It's hard to contain, and these cause like very real challenges for the new world order. With that, I think it's a good. I wanted to segue into this topic that I could tell that you're really excited about, which is kind of the application of AI to all industries in the world. And we like to use this term, this sort of AI industrial revolution. And one of the incredible things about AI is just how broadly applicable the technology is. As you mentioned, it can be applied to most industries in some way that is deeply transformative, and it can be used across most of these domains to really great benefit, almost very uniquely from any other technology. If you think about the internet or software, those were most of the value there was actually generated by creating almost new domains or new ecosystem environments. But AI has this ability to be maybe more foundational, maybe more cross-cutting into many of the existing industries. So what technology analogy do you think is best suited for thinking through AI and its implications? Do you think it's more like sort of the computer, more like the internet, more like electricity? What do you think that the right analogy there is?
It's hard to know. I mean, electricity was pretty important too. And I lived through the personal, the mainframe revolution, the personal computer revolution, and each revolution has seemed bigger and more impactful than the last. So it's fair to say that AI and ML are world-changing, norms-changing, and especially because they tend to work on information spaces. So one of the ways to understand how society works is society has mores, and values that are embedded in information space, which each of us is raised in and lives in. So let's imagine a situation where you have AI systems that are shifting it. How do we want to deal with that? A simple example is that you have a 2-year-old, you get a 2-year-old toy that can speak to it. At 3, the 3-year-old gets a smarter toy. By the time the kid is 10, this toy that's been upgraded, of course, is by far his or her best friend. What happens when the best friend tells it something wrong, or encourages bad behavior, or observes bad behavior? We've never had a situation where we've had a human kind of intelligence that's on par with how humans raise their children, operates their society, and so forth. There are obvious examples from misinformation. So today we already have a misinformation problem. Well, because of targeting, AI systems will be able to learn which human biases, these are recency bias and so forth and so on, to exploit to get you even more passionate about something which is false. And that cannot be good. So in the same sense that you have the damage that's possible in the information space because of this targeting, and because we live in an information space, you have this extraordinary gains that will occur with savants that can help you understand specific fields. Let's look at synthetic biology. So synthetic biology can be understood as like ECAD way back when, in that you're basically building biological organisms, but you're not making copies, right? They work differently, but biology is a lot about coming to I may not say this correctly, to the lowest energy state in any of the formulations of the atoms and molecules and the things that are synthesized around them. And machine learning is very, very good at doing that. So machine learning is very, very good at guessing which set of compounds, for example, will improve or make worse this outcome. And I'll give you an example. There's a drug in MIT called Halcyon. It's a combination between synthetic biologists and computer scientists. And the synthetic biologist said, we want to build a new general purpose antibiotic, right? Like the ones we already have. There hasn't been one in decades. And people have obviously been looking. So what they did is collectively they organized the system to generate as many compounds as they could that had some kind of antibiotic resistance. And then they did a further network that looked for the ones that were farthest away from the current ones. And they came up with a compound which is now in various forms of trial called Halcyon. Now that's something that humans couldn't do, and I think it's going to work. Because you know the story of AlphaGo and Alpha Chess, that not only did they beat the humans, which was a surprise in the case of AlphaGo in 2016, and caused a massive, massive reaction to that in China, but more importantly, they discovered new moves in games that are 2,000 years old. Now that's extraordinary. So example after example, where the simple ones are parts management in your inventory, right? That's an easy one. That's essentially a prediction. But why don't we do one where when I go to the hospital, it predicts what I'm showing up in the hospital for. And let's see how well that works. That'll help the doctors, right? Because although I think of myself as distinct, I'm genetically very similar to 999 other humans. I just don't know them. But the computer can find them and say, well, they all had this problem. Eric has the same problem.
Totally. Yeah, I want to dive into two pieces that you had just mentioned here. And so the first is the scientific, and the second is the economic implications. One of the things that I'm equally excited about is how AI is actually being successfully applied to science, whether it be biology, drug discovery, material science, et cetera. And to exactly what you just mentioned, it allows us, AI has enabled us to do significantly more of the science digitally and very, very efficiently on computer, which takes out, many fields like biology or physics or material science or whatnot, takes out a lot of the costly components of actually doing the science, which is the alternative is you have a bunch of scientists and they have to do work in a lab, and it's just very, very costly. It's meaningfully different. What do you think are the scientific implications of this? One thing that's been noted is that over the past few decades, scientific discovery has actually slowed over time. Do you think that this results in a sort of like renaissance or a reacceleration of scientific discovery?
It should be a renaissance. And I'll give you an example. I'm one of the funders of an important project at Caltech, which is trying to do essentially a new forecasting model for climate change. And this particular group focused on clouds. And I was not aware that it's impossible to simulate clouds using Navier-Stokes because of the number of equations and computation. And computers, not even all the computers in the world will be fast enough to really simulate them. But it turns out that you can learn an approximation of how clouds work that's quite workable. I was in another meeting where there was a need to understand, it's hard to describe, whether a mouse was sleeping or not. And I won't bore you with why they needed to know this. And it's very difficult to tell if a mouse is sleeping, so they didn't have very good labeled data. So what they did is they built a natural model of the physics of sleeping for a mouse, and then they generated the training data for synthetic mice sleeping. And they built successfully a model that would tell them whether the mouse was asleep or not. Now, this is humorous, but it's really quite an accomplishment. They knew the laws of physics. They had no training data, right? They generated the training data, and they were able to do it. So a simple formula for you is that sometimes in science, AI is used to approximate a function. We don't know the function at all, or we can't compute it. Quantum chromodynamics is another good example. There's just not enough computers in the world, and nor will there ever be to get this stuff right. And so you need an approximation, and the approximation works really well. The other aspect of science is this generative part, where you can generate new things and you can try them. They're both very important. Most science progress seems to me to occur after the development of a new instrument, a new microscope, if you will. And the problem with things like spectrographs and so forth is that they're very, very expensive to operate at scale. So with these techniques, we can use existing data, existing databases, and natural data, physics simulations, and so forth, and we can really break through that limit. So that's why we should imagine that what you said is true, and that you'll see these breakthroughs. And if you care about climate change, which I do a lot, this will probably be the thing that will allow us to address it through innovation, because the current approaches are just not working well enough.
Yeah. And you had alluded to this before, where you'd mentioned, hey, if AI is actually able to insert into each one of these industries and each one of these scientific pursuits and drive breakthroughs, that's going to result in trillions of dollars of value over the next few decades. And I'm curious to dig into that model a little bit more deeply. What do you think are the economic implications of AI being scalably applied to every single industry and scientific area?
So let's talk about industries that are not regulated or lightly regulated. Those industries will fairly quickly be disrupted by these techniques because either an existing company or a new company will adopt them, and they really will solve the problem better. And that will then create a crisis for the number 2, number 3, number 4. And that's called capitalism. When that happens, there's an awful lot of destruction of jobs and of shareholder wealth, as well as winning and so forth. And so the question is, in aggregate, do you create more jobs or less jobs? And unless we make a few changes in the way we operate, we'll probably end up with less, at least high quality jobs. And the reason is that the winners tend to be concentrated and they tend to get more of the spoils. There are other jobs available, but they're not very interesting ones. And so I think that along the way with this technology, it's super important that we figure out a way to use AI to solve some of the problems that have bedeviled us. I'm familiar with a company that is using AI to try to determine why certain parole officers put everyone that they see into jail for parole violations and others don't. That's an example of a real human crisis for those people involved. That's an inefficiency in our market. So overall, I'm just using that as an example. There are 1,000 such examples. We need to figure out a way to use these tools to produce a better educated and more empowered and higher income workforce. If we don't, the Gini coefficient, literally the gap between the richest and the poorest in every society, is going to increase, and that's clearly not good.
Yeah. And what do you think are some of the one of the very interesting things about many of the recent advancements in AI is that if you look at where the advancements are happening, it's actually cognitive work that is being more successfully automated. You look at the Codex or Copilot systems out of OpenAI and Microsoft. You look at AlphaFold coming out of DeepMind, and these are esoteric skills or skills that are difficult to train humans on, but they're being automated very well, partially because they're so digital in nature. What do you think of the implications of this, where at the same time, sort of more manual skills are actually much harder to automate? Robotics has been sort of this devilishly hard problem for a very long time. Self-driving has been a hard problem. How do you think this plays out over the course of the next 5 to 10 years?
Well, I think it's reasonable to expect we're going to see in purely digital industries extremely rapid change from the AI platforms and the universal models. If you take a look at GPT-3 and then the products that Microsoft is offering now around coding, that's a good example where in programming you get a return signal, you get a reward signal. Did they like my suggestion? So it's reasonably obvious that if you have a big enough model and you have a big enough training set, you should be able to build quite a good product. And I'm sure that that's their strategy. I also know that they have competitors coming. So not only do you have them, but you have 3 or 4 competitors who will be well funded. That collectively will move that industry forward. And who wouldn't want the computer to help them write their code anyway? That would benefit everybody. So I think you're going to see that much more quickly than you'll see some of these other industries. The industries that move the slowest are the ones that are not subject to commercial or regulatory pressure. Most regulated industries, the companies and the regulators essentially have worked it out, and so they tend to agree on everything, and they tend to be difficult for new entrants to enter. So if the result is a partitioning between regulated industries where it's very hard to enter, and then this incredibly fast evolution on the unregulated side, that will create other problems and other disparities. The simplest way to think about it is, if you're not offering the equivalent of an Android and iPhone app to do anything, what's wrong with you? Right? So today, someone your age and your generation says, like, why do I have to carry a passport? Right? Why do I have to go to a bank? Why do I have a vaccination card? These all seem dinosaur strategies, and yet they made sense 20 years ago. So I think you're also seeing a situation where the rate of change is outstripping humans' ability to change it. My own view is that the rate of change in the next 10 to 20 years will be much faster than the last 10 years. And boy, what a 10 years that has been, because of the compounding. You have the situation where it's combinatorial innovation. Each layer builds on the top, and those layers are getting filled in very, very quickly. So if you start with the presumption of in every business and in every task, there's some learning function, we just have to find it, then you can probably build a killer app. The most obvious one that I would like to emphasize here is education. You have all the things you need. You have a lot of students, you have a lot of learning, you have a lot of quick clicks or equivalent of clicks. Why have we not figured out the optimal way, literally the scientifically optimal way to teach English, math, physics, science, and so forth? I'm busy funding some of this activity, but it's amazing to me that you have this immense education industry, right, which is many percentage points of GDP, and almost no innovation in the underlying science, literally the computer science of learning in the field. And it's an oversight that we need to correct.
Yeah, 100%. You know, so I think I agree with you, which is that the sort of one of the fundamental shifts at a sort of physics of business perspective, you know, one of the things that happened when we had software was that all of a sudden you had this thing that was free to replicate. That was like a big change, you know, it changed how we thought about many things. One thing that you're mentioning is now with AI or with machine learning algorithms, you have this new physics that is occurring, which is systems that just get better very, very, very quickly, that have compounding improvement to quality and effectiveness and functionality. So one of the things, so that's sort of maybe the underlying node that's changing. But
can I just add? Let me just add that when we started all of this, you know, I've been doing this now for 45 plus years. It never occurred to me that we would end up with this amount of concentration of power in countries in the form of China and in companies in the form of the US leading companies. The entire vision of technology, which of course all of this the internet all came out of Vietnam and the Vietnam anti-war movement, was decentralized control, not centralized control, freedom of the individuals. Remember the end-to-end principle in the internet. So it's important to understand that the structure we have now, where you have this concentration of power, which is both economic, social, moral, regulated, and so forth, again, using China and the US, that may not ultimately be the state. This may be a situation where the technologies go from centralized to decentralized to centralized to decentralized. And it's presumed that the Chinese model of authoritarian control is going to be the dominant one. But I can imagine that with the empowerment of these models, giving each person their own supercomputer identity human friend, they're going to be a lot more powerful too. And I don't think we understand this. And it's canonic to say everything will be structured, everything will be hierarchical, and these big companies will be formed. But let's imagine that in your next company you found one that builds the assistant that helps everyone get through life. Is that company going to be a bigger company than the current companies? If you pulled it off, yeah, you would be. And you would also be regulated to death, right? Now, what happens instead is, let's say that you do this after your current company, and there are 100, and no single one becomes dominant because they're all specialized, right? That in fact, people are different enough that there's no single market. I just don't think we know.
Yeah. Well, this is a great segue to, I think, one of the last questions, which is if we think really far out, what are the changes to how business is done? And, you know, if you really look at it, my view is if you look at sort of the last generations of technology, the internet, the personal computer, the phone, et cetera, there's effectively been three business models that over time dominated. There's ads, which you know a lot about. There's enterprise software, which you also know a lot about, and e-commerce, which we have in the United States. It's huge in China, massive, massive in China. And those have been sort of like the three dominant business models that technology has really enabled. What do you think are the new sorts of business models that potentially are going to exist because of the advent of AI or these new technologies that are being integrated?
Well, we've talked about for decades that there will eventually be micropayments of one kind or another. And we're still waiting for those micropayments. It makes sense to me that advertising, sponsorships, subsidies, all of those will be part of it. But at the end of the day, I have a different way of thinking about it, which is just build a product that's 10 times better than the incumbents. Now, when I didn't say 10%, I said 10 times. If it's 10 times better, then none of these things matter because it'll all come to you. Now, if it's 10%, the incumbents have such strong incumbency benefits, including regulatory capture, brands, and so forth and so on, that the standard is high. I think that with AI, you have an opportunity across most fields to build a better mousetrap for sorry to use mice as an example, in pretty much every industry. And it's not just AI. Most industries do not do digital design. So for example, there's a concept called digital twinning, where you build an entire software version of the thing you're going to build. This is now done in the car industry, for example. Most of the manufacturing industries are not doing it. Most industries still do things the way they were done 10 or 20 years ago at the human level. For every one of those, there is a new way of coming in with a sharp technical team using the data and learning the outcome quicker. Tech is the first one because we're the tip of the spear. We have the best training environment. We don't have the regulatory requirement. We don't have the capital cost, but the same applies to all these others. I'm not worried about the monetization. I'm worried about getting users. If you can basically get users and get a growing business, trust me, we can make money. We can make money by licensing, selling, transferring the technology. We can build widgets. We can build another widget. We can sell that and so forth. People always blame the revenue because they didn't have a good revenue plan. Why don't you just build a great product? Right? If you have a great product, your customers will come to you.
Yep. And this has been super wonderful. I want to close on one important question, one that I know that you've thought a lot about, and this could be viewed as almost like a call to action to the audience we have today. You know, the common moonshot associated with AI is often AGI, which could be very, very far in the future, and who knows exactly what it means anyway. But one of the things that I'm really excited about is like, what are the other grand challenges of AI that might be sooner that we can all get really excited about? So you mentioned climate change earlier, which is one that you're personally very excited about. What do you think are the big grand challenges of AI that are soon, but also deeply important?
Well, what I've noticed is that the simple formulation of basically traditional learning, self-supervised learning, partially supervised learning, and so forth, those were last year's scenario. What people are doing now is they're building extremely sophisticated multi-model reasoning systems. They generate a set of candidates, and then they get rid of those candidates in some other way, and then they do something else. So there's typically a 2 or 3 stage pipeline. And getting that pipeline right is the job of, whether we like it or not, PhDs in those areas, because they really have to understand at a very deep level what this network is doing. I wish the network could sort of figure that itself out, but we don't know how to do that yet. So it seems to me that the greatest short-term opportunity is to build enough of an infrastructure that these powerful models can be done by master's students instead of PhD students. Historically in tech, this stuff started by PhD students building it, and then it became common. You won't remember this, but there was a time when email was considered a vertical. Right? It was sort of something that you added, you had to buy, right? And then it became, we used to say it was vertical and went to horizontal. It became part of the platform. I want in software for the tools that we're describing now to be so commonplace that people of, let's just say, relatively normal technical education can master them. The problem in our field today is it fundamentally takes a PhD in math or physics or computer science to understand what these things are doing. And that's not a good long-term situation. The digitization, the process of digitizing the world, is a massive business. It's a massive calling. There's lots and lots of opportunities. But we're too reliant now on these very rare specialists, men and women who are really, really good at this, and we need to make it more common. It's the old thing of, we talk about the top universities, and they certainly have a big impact. But the universities that have the biggest impact are the large state schools that generate so many people that fill the companies of the country. So let's focus on that too. Let's focus on making the tools for them such that they can really do sexy stuff, right? But they don't have to understand it. When I started as a computer scientist, the first thing they taught me was bubble sort. My guess is that there's about a zillion GitHub bubble sort and sorting algorithms. And why do I really need to understand that, except that I had to get a good grade in my class? Right? Why do I need to understand how to make modems work, which I used to do? Right? All of that stuff should be elided. And so the notion of progress is platform progress. We used to worry about things like language scanners and translation and so forth and so on. All of that stuff should be excerpted so that the programmers that we work with are working on the really hard problems. And furthermore, ideally, with these universal programming models, coding models, that the computer will help you figure out how to solve the problem.
Yeah, it's a great call to action. It's something that I think many people in the community are really passionate about, is how do we democratize AI and machine learning and make it accessible to all? Well, with that, that's it.
And look, I mean, just take the stuff you're doing and show it to your roommate, who'll go, like, what? What are you doing? I mean, try to get it so that you can even explain to a reasonably normal, intelligent person how these systems work, and then figure out a way to build models and that's always how we work. And by the way, I mentioned open source and GitHub. I was part of the open source movement when it was started. And the open source is critical for the knowledge sharing that goes on, because people share the stuff, and we really do move faster because of sharing. So if you go back to your earlier point about the scientific discoveries are slowing down and so forth, how do we accelerate that? We work together to build very powerful knowledge platforms that the next generation, which in your industry is every year or two, can build the next generation of app on. And that app solves a really important problem.
Amazing call out. Well, thank you so much for taking the time today, Eric. This was a really interesting conversation. We covered a lot, and excited to chat next.
Okay, thanks, Alex, and I'll see you soon.